Okay, so now that we've learned how to simplify square roots, let's see what happens when square roots are in equations. So first of all, of course, how do I solve equations that involve a square root? But also, what is this thing called an extraneous solution? We haven't seen any of these yet this year, but as it turns out, sometimes when you solve an equation, there's a solution that looks like a solution, but it's not. And we're going to see what those look like here. So, because of these extraneous solutions, it's like a gold mine for memes. So here's a meme that mentions extraneous solutions. And here are two more. But my grand favorite is this one. I love the condescending Wonka meme. So anyway, yes, don't forget to check for extraneous solutions. All right, so let's actually start solving these problems, and we'll find out what the extraneous solutions look like. Okay, so we have a square root in our function. Now, I'm going to solve this just like I normally would. So last chapter, we learned a lot about the zero product property, factoring, all these things. But I'm going back to basics. I'm just going to try to cancel. And remember that when we're canceling, we try to work in reverse PEMDAS because we're canceling things. We're going backwards. So since addition and subtraction are at the bottom, let's cancel this first in my quest to get x by itself. Next, multiplication and division. We must divide by 2 in my quest to get x by itself. And finally, I have a square root over the x. Now, how do I cancel the square roots? Well, let's think about what the opposite of a square root is. I know that the opposite of multiplying is dividing. I know that the opposite of subtracting is adding. And we learned this last chapter. We totally did. We just did it backwards. When I had x squared, I would square root. So in the same way, isn't it true that the opposite of a square root is a square? If I square both sides, that cancels the square root, and I'm left with x equals 16. And you can probably also think about this intuitively, like, what could I square root to get 4? Well, obviously the square root of 16 is 4. Now, there are these things called extraneous solutions, and so we need to be very careful that we don't have one of these. Remember, they look like solutions, but they're not. So let's just double check my equation by plugging 16 back in. So I have 2 times the square root of 16 minus 8. I need to make sure that equals 0. Now we're working forward in the order of operations. So let's do the square root first. Let's do the multiplication next, and 8 minus 8 is 0, which is what it's supposed to equal 0. So this is not an extraneous solution. This is a solution that actually does work. I checked it. All right, next example. So again, here we're going to be working in reverse PEMDAS order. Notice that inside the square root, there's the minus 7. Don't think that doing reverse PEMDAS means adding 7 to both sides. Don't do that. This is like parentheses, so we actually need to cancel that minus 7 last. I'm going to start with the minus 12, so I'll subtract 12 from each side. I have 4 root x minus 7 equals 16. Next, in order of operations, reverse. What am I going to cancel next? The 4. So I have square root x minus 7 equals 4. Next, I know that this is complicated, but it's underneath a square root, and what's the opposite of a square root again? Squaring. So when I square both sides, I'm left with just x minus 7 equals 16, and then finally I can add 7 to both sides now that it is no longer under the square root. Notice that when I square both sides, this is what I saw a couple people doing on the test on that bonus question, it doesn't make this x squared minus 49. No, because the square root and the square, they just cancel. And so what are you left with? You're left with the x minus 7. The square does not somehow distribute in. That's not how it works. So x equals 23 is my answer. Now again, we need to plug this back up into the equation to make sure. So let's see if it works. We can kind of do it in our head. 23 minus 7. Well, that's 16. The square root of 16 is 4. And 4 times 4 is 16. Is 16 plus 12, 28? Yeah, you bet. So this is an answer that does work. So mister, when are all these extraneous solutions going to come up? Well, they will, I promise. All right, next one. I have a square root on both sides. Now, I'm not allowed to add 1. That's not how it works. because that one is trapped under the square root. But let's just focus on this side for now. If I have a square root on this side, how can I cancel that square root? Well, couldn't I just square both sides? When I square, that's going to cancel the square root, and I'm just left with 3 minus 2x. But if I square this side, don't I also have to square this side? And notice what happens on the other side. The side kind of looks exactly the same. It's all being square rooted. Likewise here, the square root actually cancels the square, and I'm just left with -1 minus x. Pretty cool. Now at this point, I have an x on both sides of the equations. I need to do a little effort to get my like terms together. So let's add 2x to both sides. That cancels it here. I have 1x on this side. I'll just write it out since it's been a while since we did these. Now it's easy. I can add 1. So it looks like, oh, this is just 1x. So I've solved it. Nice. So x equals 4. But let's check to make sure this works. So square root of 3 minus 2x. And let's see, when I plug a 4 in here, I'll have the square root of 3 minus 8, right? Uh-oh, what's the issue here? On this side, when I plug 4 in, I'm going to have to take the square root of a negative answer. But I know that can't happen. So even though this answer looks right, when I actually go to plug it into the formula, I end up taking the square root of a negative number, which I know can't happen. So this answer, even though it looks right, and even though we solved it and it seemed to work out right, when I actually went and plugged it back in, I was getting the square root of a negative answer. So this answer is false. It is an extraneous solution, and since that was the only solution, but it didn't actually work, this one actually ends up being a no solution. Interesting. So even though it looks like I got a solution, it didn't work. No solution. All right, let's just do one more example. Oh, I need to throw in a joke. How fun is this math, you guys? Yeah. All right, so this one. Uh-oh. I have an x on both sides of the equation. Also, I have a square root. This is really weird, but really the only thing that's making this equation hard is the fact that I have a square root here. And as long as this square root's here, oh, I'm recording this at school, there's the bell. As long as I have this square root here, I don't really know what to do. So let's square both sides, because that'll get rid of it, right? Now I have 6 minus x equals, well, just x squared, right? Oh, look at this. This is fun. Did you think quadratic equations would go away? They don't. Look, I have a quadratic equation now because I have a square. So what are my steps? Remember how to solve a quadratic equation? First, I need to get a 0. So let's subtract 6 and add x. So plus x minus 6. So I have 0 equals x squared plus x minus 6. Second, let's factor. This would be... the risks of recording at school, I actually just got interrupted. Anyway, this factoring is x plus 3 times x minus 2. Are you starting to get good at factoring? Are you starting to be able to do it in your sleep? That's how it is for me, but I'm the teacher, so I don't know if that matters. Finally, zero product property. We know that x equals -3 or x equals 2. Okay, so either one of these solutions, but especially in these sorts of problems where there are two solutions, it's actually more common that one of them could be extraneous. So let's check the -3 first. So I'm plugging in everywhere I see an x. And I'm already a little concerned because look, can I take the square root and get a negative? I don't think so. So let's see what happens here. I have the square root, 6 minus -3 is 9. But the square root of 9, we consider that to be 3. Like, I know we said last chapter when you were square rooting within an equation. Interrupted again. One sec. Always bugging. I'm about to get interrupted again. But the point is, 3 equals -3 because the square root is positive. So it doesn't work. It's an extraneous solution. Okay, so we still need to check the other options. So let's see what happens when we plug 2 in. If I have the square root of 6 minus 2, that'd be the square root of 4. And the square root of 4 is 2. So this one does work. So here's an example of a problem where the one answer, because of the negative, actually doesn't work. So I only end up having one answer here. So here's your summary. First of all, watch out for extraneous solution. You must always check your answer because sometimes they won't work. And obviously, if you want to cancel a square root, just square both sides. Thanks for watching.